Hey everyone, welcome! Today we're diving into the fascinating world of math, where we'll uncover the secrets behind linear and quadratic equations. Get ready to put on your detective hats. Today we're going to become detectives of math. Just like detectives solve mysteries, we'll solve the mystery of how to identify linear and quadratic relationships in various scenarios. We're going to learn how to spot the difference between linear and quadratic relationships in real-world scenarios. This skill will help you understand how different patterns and trends work in everyday life. Let's start with linear relationships. These are the simpler of the two, and are often easier to identify. Think of a straight line. It's simple, direct, and consistent. That's what a linear equation looks like when you graph it. No matter where you look on the line, the rate of change remains the same. What's special about a straight line? It's the consistency that makes it unique. It has a constant rate of change. This means that for every unit you move in one direction, you move a consistent amount in the other direction. That means for every step you take in one direction, you take a consistent step in the other. Imagine walking up a staircase where each step is the same height. Imagine you're driving a car at a steady 50 miles per hour. No matter how long you drive, your speed doesn't change. Your distance increases by 50 miles for every hour you drive. That's a linear relationship. You see? It's predictable and easy to follow. A constant speed creates a straight line on a graph. Easy, right? This is why linear relationships are often used to model simple, predictable scenarios. Now let's look at quadratic relationships. These are a bit more complex but equally fascinating. These create a curve called a parabola. Unlike a straight line, a parabola has a distinct shape that changes direction. Think of a ball thrown into the air. It doesn't just go up and come straight down, it follows a curved path. It goes up, slows down, reaches its peak, and then comes back down. This entire motion forms a parabola, which is shaped like an arch. Notice how the speed changes? It's not constant like in a linear relationship. What do you notice about the ball's path? It slows down as it goes up and speeds up as it comes down. This change in speed is due to gravity acting on the ball. That's because gravity is constantly changing the ball's velocity. This varying rate of change is what makes quadratic relationships unique. This changing rate of change is the hallmark of a quadratic relationship. It's what gives the parabola its distinctive shape. So how do we spot these relationships in the real world? Ask yourself, is the rate of change constant or does it vary? Is the rate of change constant? If it is, you're likely looking at a linear relationship. Does it form a straight line or does it curve? If it curves, you're probably dealing with a quadratic relationship. If the answer is yes to the first two, it's linear. Linear relationships are straightforward and easy to predict. If it curves and the rate of change is constantly changing, it's likely quadratic. Quadratic relationships are more dynamic and can model more complex scenarios. Let's look at some examples. These will help solidify your understanding of linear and quadratic relationships. This tap filling a bucket at a constant rate, linear, the water level rises steadily over time. This rocket launching into the air, affected by gravity, quadratic. The rocket's path follows a parabolic curve due to the changing forces acting on it. Now let's test your detective skills. Can you identify whether a scenario is linear or quadratic? Is this scenario linear or quadratic? Choose your answer. Great job. Remember, practice makes perfect. Look for that constant rate of change for linear and the changing rate of change for quadratic. These clues will help you identify the type of relationship. Keep practicing, and you'll become a pro at spotting these relationships. You've got this. Keep exploring math. The more you practice, the better you'll get at identifying these patterns in the world around you.